Think all truck engines are built tough? Think again. From underpowered gas guzzlers to diesel disasters, these engines left drivers stranded, wallets empty, and mechanics shaking their heads. Today, we're counting down the 50 worst truck engines of all time. The ones that blew head gaskets, snapped timing chains, and turned dreams into nightmares. Buckle up. This is going to get ugly. Let's kick things off at number 50 with the GM 5.7-liter Oldsmobile Diesel V8. GM's attempt at a budget-friendly diesel in the late 70s led to one of the worst pickup truck engines of all time, the 5.7-liter Oldsmobile Diesel V8. Slotted into the Chevy and GMC CK1500 and 2500, this engine was supposed to deliver the fuel economy of a diesel without the cost of developing a real one. Instead, GM took their existing 350 cubic inch Oldsmobile gas V8, modified it for diesel, and hoped for the best. Spoiler alert, it was a disaster. This wasn't a purpose-built diesel. It was a gas block with higher 22.5-to-1 compression, and that's where the problem started. The head bolts were too weak to handle the pressure, stretching over time and leading to blown head gaskets. The block itself wasn't reinforced enough, resulting in cracks in the main webs and lifter valley. Early models didn't even have a water separator, so water contamination quickly killed the fragile Stanadyne DB2 injection pump, leading to hard starts and complete fuel system failure. The glow plug system was also unreliable, meaning cold starts were often a nightmare. Add in soft camshafts that wore down prematurely and weak main bearings that couldn't handle diesel loads, and you had an engine that was practically guaranteed to self-destruct before hitting 50,000 miles. GM tried to fix it with multiple revisions, but by 1985, the damage was done. Warranty claims and lawsuits piled up, and the 5.7-liter Oldsmobile diesel became one of the biggest black marks in GM's history. Up next at number 49 is the Ford 6-liter Power Stroke Diesel V8. If you've ever heard a diesel guy groan at the mention of the 6-liter Power Stroke, there's a reason. Found in 2003 to 2007 Ford F-250 and F-350 Super Duty pickups, this engine was supposed to be a modern, emissions-friendly powerhouse. But it turned into one of the most infamous diesel disasters in truck history. The problem, though, was in power. The 6-liter made 325 horsepower and 560 foot-pounds of torque. I realized I've been saying that stat wrong this whole time I've been doing these videos, so I decided to correct myself. I heard your comments. Solid numbers for the time. The issue was reliability, or rather, the complete lack of it. The EGR system was a ticking time bomb. The EGR coolers would crack and dump coolant into the intake, leading to hydrolocked engines. Then there were the head gaskets. Weak factory head bolts couldn't handle the boost pressure, causing catastrophic gasket failures. And let's not forget the high-pressure oil pump, a crucial component for fuel injection. When it failed, and it often did, your truck wasn't going anywhere. Oh, and the fuel injectors. They relied on the same high-pressure oil system, so when things went south, they either clogged, stuck open, or just quit entirely. To top it off, the turbo vanes were notorious for sticking due to soot buildup, meaning inconsistent boost and erratic power delivery. Ford owners spent thousands bulletproofing these engines, upgraded head studs, EGR deletes, aftermarket H-pops, just to make them somewhat reliable. Ford and Navistar, the engine's manufacturer, pointed fingers at each other, but by 2007, the damage was done and Ford moved on. And moving on to number 48, it's the Ford 6.4-liter Power Stroke Diesel V8. Just when Ford truck owners thought things couldn't get worse after the 6-liter disaster, along came the 6.4-liter Power Stroke. Used in 2008 to 2010 Ford F-250 and Ford F-350 Super Duty pickups, this engine was supposed to be a clean sheet improvement. However, it somehow made things even worse. The biggest issue? It was Ford's first common rail diesel, and while that meant better performance, 350 horsepower, 650 foot-pounds of torque, it also introduced a laundry list of new problems, the twin-turbo setup. Cool in theory, but was prone to oil leaks, shaft failures, and carbon buildup. Worse, the pistons had a habit of cracking under high load, often leading to complete engine failure. If the pistons didn't take you out, the cracked radiators or constant fuel dilution issue would. Speaking of fuel dilution, the engine's regeneration system dumped raw diesel into the crankcase to burn off soot in the DPF. That meant rising oil levels, thinned out lubrication, and eventually wiped out bearings. Add in a problematic high-pressure fuel pump, prone to grenading and sending metal through the system, and you had a diesel that was just waiting to self-destruct. The 6.4-liter was so bad that Ford ditched Navistar completely after this mess. By 2011, the 6.7-liter Power Stroke arrived, and Ford truck owners finally had an engine they could trust again. At 47, it is the Dodge 2.2-liter i4. A four-cylinder in a pickup is already a tough sell, but Dodge took it to another level with the 2.2-liter i4. Dropped into the Ram 50 in the first-gen Dakota, this tiny motor was meant to give buyers an efficient, budget-friendly option. What they got was an engine that barely moved the truck and had a habit of self-destructing. With just 96 horsepower and 119 foot-pounds of torque, the 2.2-liter struggled with even the lightest loads. Highway speeds? Good luck. Merging required a prayer and a long stretch of road. But the real nightmare was under the hood. These engines ate head gaskets for breakfast, thanks to weak cooling system design and a block that couldn't handle heat cycles. Overheating was common, warping the head and leading to constant leaks. The valve train wasn't much better. Soft cam lobes wore down prematurely, causing misfires and low power. Oil consumption skyrocketed as piston rings wore out, and by 100,000 miles, many of these engines were either burning oil like a two-stroke or had already been scrapped. Dodge eventually moved on, offering a Mitsubishi 2.6-liter and later the more capable 3.9-liter V6. The 2.2-liter, however, remains one of the weakest and most failure-prone truck engines Dodge ever built. Up next at 46, it's the Nissan 2.8-liter L28 diesel i6. Diesel engines are supposed to be tough, long-lasting workhorses. Nissan must have missed that memo when they stuffed the 2.8-liter L28 diesel i6 into the 1980 to 1983 Datsun 720 pickup. What should have been a reliable alternative to Toyota's bulletproof diesel ended up being one of Nissan's biggest misfires in the truck world. At first glance, the L28 diesel seemed promising. Based on Nissan's legendary L-Series gas engines, it had a strong inline-six layout. But the problem? This wasn't a true diesel design. Nissan modified the L28 gas engine, much like GM did with the infamous 5.7-liter Olds diesel, and ran into similar catastrophic issues. The block wasn't reinforced for diesel compression, leading to premature cracks and internal failures. Wow, I can't believe that happened. The fuel system was another weak point, with the injection pump frequently losing prime, causing hard starts, rough idling, and eventually complete failure. Cooling issues were common, thanks to an undersized radiator and poorly designed water jackets. Overheating led to warped heads, blown head gaskets, and excessive oil consumption. To make things worse, Nissan didn't sell enough of these engines to justify widespread support, so parts quickly became scarce. By the mid-'80s, most owners had either swapped in a gas engine or scrapped the truck entirely. Nissan quietly retired the L28 diesel, shifting focus to more reliable four-cylinder diesels. But for the few who owned one, this engine was an expensive lesson in what happens when a gas motor pretends to be a diesel. Coming in at number 45 is the Chevy 267 cubic inch V8. The Chevy 267 cubic inch V8 might just be the most pointless small block Chevy ever built. Introduced in 1979 for the CK series pickups, this engine was GM's half-baked attempt to offer a fuel-efficient V8 during the gas crisis. Instead, it delivered the worst of both worlds: weak power, terrible fuel economy, and no performance potential. It was such a dud that even GM quietly axed it after just 4 years. On paper, it looked like a small block Chevy, but it was missing everything that made the platform great. With a tiny 3.5-inch bore, the 267 couldn't even fit GM's bigger performance heads, meaning no room for improvement. It made a pathetic 115 to 125 horsepower and 200 foot-pounds of torque, barely more than Chevy's 6-cylinders of the era. For a work truck, this was a disaster. Acceleration was non-existent, towing was a joke, and passing on the highway required divine intervention. And it wasn't just slow, it was inefficient. The tiny bore, restrictive heads, and small 2-barrel carburetor forced the engine to work harder, killing any fuel economy advantage. Owners reported getting the same, or worse mileage, than a 350 V8 while struggling to haul anything heavier than groceries. Reliability wasn't awful, but it didn't matter. Nobody wanted one. By 1982, GM pulled the plug, and the 267 was quickly forgotten, buried under the weight of better small blocks. Number 44, it's the Dodge 3.9-liter Magnum V6. Dodge's 3.9-liter Magnum V6 was supposed to be a solid, fuel-efficient alternative to a V8 for mid-size Dakota and full-size Ram 1500 buyers. Instead, it was nothing more than a 5.2-liter V8 with 2 cylinders lopped off, and it ran exactly like that, underpowered, unrefined, and thirsty. Introduced in 1987, this V6 stuck around for over a decade despite never excelling in any category. The biggest failure of the 3.9-liter was its power-to-efficiency ratio, making just 125 to 175 horsepower across its lifespan. It delivered V8-level fuel consumption with the performance of a 4-cylinder. In a Dakota, it felt sluggish. In a Ram 1500, it was completely gutless. Low-end torque was weak, and towing anything beyond an empty trailer pushed it to its limits. While Dodge tried to address power issues with the Magnum update in 1992, adding fuel injection and better heads, it was still outclassed by competing V6s and fell miles behind even the weakest V8s. Durability wasn't much better. The 3.9-liter was notorious for intake manifold gasket failures, leading to vacuum leaks and oil consumption. Premature timing chain wear caused excessive engine noise and sloppy performance. Many engines developed lifter noise and valve seat failures, with high-mileage units often suffering from bottom-end wear. By the time Dodge finally retired it in 2003, no one was mourning its loss. At number 43, it's the Chevy 5.3-liter Vortec V8. For years, the 5.3-liter Vortec V8 had a solid reputation across the industry. Reliable, efficient, and a great balance between power and fuel economy in the Silverado 1500. But that all changed when active fuel management lifter failures started appearing in massive numbers around 2019, turning a once-respected engine into a costly liability. GM designed AFM to deactivate cylinders under light loads for better fuel economy, but in reality, it led to excessive oil consumption. The deactivated cylinders allowed oil to slip past the rings, causing many owners to burn a quart of oil every 1,000 miles or worse. GM initially dismissed the issue, offering a software update that did nothing to fix the core problem. Then came the real disaster, lifters collapsing, a catastrophic failure requiring expensive top-end repairs. By 2019, it was clear that AFM had doomed the engine, with thousands of trucks experiencing ticking noises, misfires, and complete valve train failures. The problems didn't stop there. Many 5.3 liters suffered oil pressure drops from a faulty oil pickup tube oil ring, leading to cam and lifter wear. Cracked exhaust manifolds and piston slab added to owner frustration. While some high-mileage units survived, too many required full rebuilds well before 150,000 miles. What was once a highly regarded engine became a cautionary tale of overcomplicated fuel-saving tech gone wrong. Moving on to number 42, it's the Jeep 2.1-liter Renault Turbo Diesel i4. The Jeep Comanche was supposed to be a tough, capable small pickup, but someone at AMC thought stuffing a 2.1-liter Renault Turbo Diesel i4 under the hood was a good idea. It wasn't. This French-built engine had no business in an American truck, and it quickly proved to be one of the worst diesels ever put into a pickup. Underpowered, fragile, and plagued with turbo failures, it turned the 1985 to 1987 Comanche ownership into a nightmare. Let's start with power, or the lack of it. Making just 85 horsepower and 132 foot-pounds of torque, the 2.1-liter diesel was barely enough for a compact sedan, let alone a work truck. It struggled with hills, loaded beds, and even highway speeds. Towing? Forget about it. Worse, the tiny Garrett T2 turbocharger was known for premature failure, often grenading itself before 100,000 miles. If the turbo didn't fail, the weak head gaskets did, leading to constant overheating issues. Durability was another joke. The thin-walled aluminum block and cylinder head couldn't handle the stress of even moderate loads, and cracked heads were common. The timing belt, critical for keeping the engine alive, had to be replaced religiously, or owners faced complete engine destruction. Parts were scarce, mechanics hated working on them, and by 1987, AMC had enough. The 2.1-liter diesel was unceremoniously dumped, and no one missed it. At 41, we have the Chevy 4.3-liter V6. The Chevy 4.3-liter V6 was supposed to be a dependable workhorse for light-duty trucks like the CK1500 and S10, but it turned into a mechanical headache for countless owners. While GM marketed it as a tough, small-block-derived six-cylinder, the reality was a motor plagued with intake manifold gasket failures, relentless oil consumption, and overall durability issues. The biggest Achilles heel was the plastic and rubber intake manifold gasket, a cost-cutting disaster. Over time, coolant would eat away at the gasket, leading to internal leaks that contaminated engine oil. Owners who didn't catch it in time faced spun bearings, oil sludge, and full engine failure. GM's only solution? Keep replacing these same faulty gaskets. Even later models with updated materials weren't much better. Then came the oil consumption problem. The 4.3-liter was notorious for burning oil at an alarming rate, often thanks to worn valve guide seals and weak piston rings. Many owners found themselves adding oil constantly, and if they weren't diligent, the engine would run itself dry and self-destruct. Some engines soldiered on past 200,000 miles, but many suffered from lifters ticking, main bearing wear, and weak timing chains long before then. Despite being based on the legendary small block Chevy, the 4.3-liter was a maintenance nightmare, proving that chopping off two cylinders didn't always make for a better engine. Up next at number 40, it's the Ford 4.2-liter Essex V6. This engine was a cost-cutting move that never quite earned the trust of truck owners. Ford needed something similar and more fuel-efficient than the old 4.9-liter inline-six, but what they delivered was an engine with too many weak points for long-term reliability. The most notorious failure was the timing cover gasket. Coolant would leak internally, mixing with the oil and wiping out the bearings. If left unchecked, oil starvation would destroy the bottom end, often before 100,000 miles. Early models also suffered from weak head gaskets that failed prematurely, leading to overheating and cylinder damage. The plastic intake manifold, a common problem on 90s Fords, had a habit of cracking and allowing coolant to seep into the engine. Another issue was the EGR system, which suffered from excessive carbon buildup, choking airflow and causing rough running conditions. While Ford made minor improvements over time, the Essex never developed a reputation for durability. It lacked the brute force simplicity of the old inline-six and wasn't much more efficient in real-world driving. By 2009, Ford scrapped it entirely in favor for the more modern and reliable 4.6-liter V8 and the upcoming 3.7-liter Duratec V6, leaving the Essex as one of the more forgettable truck engines of its era. On to number 39, it's the Ford 5.4-liter Triton V8. This was supposed to be a workhorse, an evolution of Ford's modular engine family designed to power everything from the Ford F-150 to the Super Duty truck. On paper, it had potential. More displacement than the 4.6-liter, decent torque, and smooth operation. In reality, it turned into a maintenance nightmare, known for a series of costly, infuriating failures that left owners, let's just say, frustrated. One of the biggest flaws was the spark plug design. Early models used a pitiful 4-thread aluminum head, which wasn't strong enough to hold the plugs under high stress. Many owners experienced plugs blowing out, stripping the threads, and requiring expensive cylinder head repairs. Later models introduced a two-piece spark plug that seemed like an improvement until people realized they had a habit of snapping off inside the engine, requiring special tools and, in worst cases, head removal. Then there were the cam phasers, a critical part of the variable valve timing system. They wore out quickly, leading to a distinct knocking sound, poor performance, and costly repairs. The timing chain setup didn't help either. Long, poorly tensioned chains developed slack over time, causing erratic timing, misfires, and eventual engine damage. While the Triton lasted well over a decade, its reputation was permanently stained by these expensive, widespread failures. At number 38 is the Chevy 6.5-liter Detroit Diesel V8. The Chevy 6.5-liter Detroit Diesel V8 was General Motors' attempt to stay competitive in the diesel pickup market without fully committing to a clean sheet turbo diesel design. Slotted into the CK2500 and 3500 pickups from 1992 to 2000, it was meant to give GM a solid alternative to the increasingly dominant Cummins and Power Stroke diesels. Instead, it became infamous for underwhelming performance, persistent reliability issues, and a fuel system that caused endless headaches. Despite having a turbocharger in later years, the engine barely made 215 horsepower and 440 foot-pounds of torque, figures that lagged behind the competition and left heavy-duty truck owners wanting more. The biggest weak point was the Stanadyne DS4 electronic injection pump, which was notoriously unreliable. Heat from the engine bay caused the PMD module to overheat and fail, leading to random stalling, hard starts, and loss of power. Owners often resorted to aftermarket relocation kits just to keep the thing running. Cooling was another disaster. Cracked cylinder heads, overheating under load, and failing water pumps were common. The engine also struggled with weak main bearing webs in the block, which could crack under stress, turning a running engine into scrap metal. By the time GM moved on to the Duramax in 2001, the 6.5-liter was already considered a relic, outclassed in both power and durability. Number 37 is the Ford 6-liter Power Stroke. The Ford 6-liter Power Stroke diesel was meant to be an improvement over the 7.3-liter, bringing more power, cleaner emissions, and modern tech to Super Duty trucks from 2003 to 2007. But it became one of the most failure-prone diesel engines ever put into a pickup, plagued by engineering flaws, fragile components, and a warranty nightmare that cost Ford and Navistar a fortune. While it made decent power at 325 horsepower and 570 foot-pounds of torque, that didn't matter when it spent more time in the shop than on the road. The biggest problem was the head bolts, only 4 per cylinder instead of the stronger 6-bolt design used in the 7.3-liter. Under boost, the heads would lift, blowing head gaskets and leading to coolant loss, overheating, and severe engine damage. The EGR system was another disaster. The cooler clogged easily, causing high exhaust gas temperatures and eventually cracking, allowing coolant to leak into the intake. This led to white smoke, overheating, and in worst cases, hydro-lock cylinders. Fuel injectors failed frequently due to debris from the high-pressure oil system, and the turbo suffered from excessive carbon buildup, causing erratic boost and sluggish response. Ford and Navistar ended up in legal battles over the warranty claims, and by 2008, the 6-liter was scrapped in favor of the 6.4-liter. Another troubled design, but that's a different story. Coming in at number 36, it's the Dodge 5.7-liter Hemi. The Dodge 5.7-liter Hemi brought serious horsepower and torque to Ram pickups starting in 2003, giving them a much-needed performance boost over aging Magnum engines. But while it delivered muscle, it also became notorious for mechanical failures that kept repair shops busy. One of the biggest design flaws was the multi-displacement system, an attempt at improving fuel economy by shutting down 4 cylinders under light throttle. In theory, it worked. In practice, it caused lifters to stick, leading to premature camshaft wear, cylinder misfires, and an unmistakable ticking sound, often a death sentence for the engine if ignored. The valve train issues didn't stop there. Lifter rollers were prone to seizing, grinding down cam lobes and sending metal debris through the oil system. Timing chains were another weak point, with tensioners that failed easily, causing slack and, in severe cases, catastrophic timing failure. Then there were the valve seats, arguably one of the most infamous problems. The press-fit design meant seats could drop into the combustion chamber without warning, shattering pistons and wrecking entire engines. While the 5.7-liter Hemi was never considered an outright failure, it was far from bulletproof. Between lifter carnage, timing failures, and sudden valve seat dropouts, it turned into a gamble. Some engines ran strong for years. Others self-destructed well before their time. Up next, at number 35, it's the Toyota 3-liter 3VZE V6. This was a frustrating contradiction. Designed for durability, yet plagued by crippling design flaws that turned it into a long-term liability. Used in the Hilux, Tacoma, and T100 between 1988 and 1995, this engine should have been a workhorse. However, it became infamous for persistent head gasket failures, poor efficiency, and a design that made maintenance a nightmare. The core issue stemmed from Toyota's decision to pair an iron block with aluminum heads. Good going, guys. This combination created uneven expansion rates, putting excessive stress on the head gaskets. Worse, the cooling system was poorly engineered, with narrow coolant passages and an inefficient flow path that allowed hot spots to develop, further weakening the gaskets over time. Toyota issued a recall to address the issue, but even revised gaskets didn't fully solve the problem, with many engines needing repeated repairs. Beyond reliability concerns, the 3VZE was simply outdated. Despite its 6-cylinder configuration, it made a lackluster 150 horsepower and 180 foot-pounds of torque. Barely an improvement over the older 22RE 4-cylinder. Its archaic single overhead cam design and restrictive intake system choked efficiency, leading to sluggish performance and abysmal fuel economy. Adding insult to injury, servicing was a nightmare. Tight engine bay clearances and an inconvenient timing belt layout made even routine maintenance time-consuming. While Toyota built its reputation on longevity, the 3VZE proved that not all of its engines were built to last. At number 34, it's the Nissan 2.5-liter YD25DDTi diesel. Found in the Navara and Pathfinder pickups, it had all the right ingredients for a solid workhorse engine: compact design, decent torque, and fuel efficiency. But in reality, it aged poorly compared to its rivals. While engines like the Toyota 1KD FTV routinely pass 400,000 miles with regular maintenance, the YD25 often started showing serious problems as early as 80,000 miles, with some failing even earlier. One of the biggest weak points was its timing chain system. Instead of a durable single-chain design, Nissan opted for a weaker secondary chain that stretched prematurely. By the time it hit 120 to 200,000 miles, the chain was notorious for rattling, throwing off timing, and in worst cases, snapping entirely, leading to catastrophic engine failure. The cylinder head design was another big problem. Made of aluminum, it was prone to cracking under heavy loads or high heat conditions. Once cracks formed, coolant loss and overheating became common, often leading to head gasket failure. Compared to the Toyota 1KD FTV's rugged cast iron block and the Isuzu 4JJ1's bulletproof internals, the YD25 simply wasn't built to last. Then came the fuel system. The common rail injectors were incredibly sensitive, with owners frequently experiencing clogged injectors and power loss at around 150 kilometers, sometimes earlier with lower quality diesel. Turbocharger issues, excessive oil consumption, and weak bottom-end bearings made longevity a serious concern. Many owners who relied on the YD25 for heavy-duty use found themselves facing costly rebuilds or outright engine replacements long before reaching the high-mileage benchmarks of its competitors. Number 33 is the Mazda 2.6-liter G6 inline-4. Found in the B2600 pickup, it's a textbook example of an engine that simply wasn't built to last. Unlike competitors like the Mitsubishi 4G64 or Isuzu's 4ZE1, both of which routinely push past 300,000 miles with proper care, the G6 often threw in the towel around 160 to 180,000 miles. Some owners didn't even make it past 120,000 miles before encountering major mechanical failures. At the heart of the problem was its chronic overheating tendency. The G6's aluminum head and iron block had a bad habit of expanding at different rates, leading to frequent head gasket failures. Once that steel let go, coolant would leak into the cylinders, causing misfires, white smoke, and eventual hydrolock. Many B2600 owners found themselves replacing head gaskets more than once, sometimes every 50,000 miles, an absurdly short interval for a pickup truck engine. Oil consumption was another glaring problem. The engine's piston rings were poorly designed, allowing excessive blow-by and oil burning well before 100,000 miles. Run the engine low on oil just once, and the bottom end was at risk. Spun bearings were common, and the weak oil pump design didn't help matters. Meanwhile, competitors like the 4G64 held oil pressure far better under stress. Then came the timing chain issues. Mazda used a single row chain with a weak tensioner, leading to excessive slack over time. By 120,000 miles, many owners reported noisy chains, erratic timing, and in severe cases, snap chains, effectively totaling the engine. Compared to the bulletproof dual-row chains found in the Toyota 22R or even the belt-driven but more reliable 4ZE1, the G6 was simply a weak design. For a pickup truck engine, durability should have been a given. Instead, the G6 became a money pit, proving that bigger displacement doesn't always mean better reliability. On to number 32 with the Mitsubishi 2.6-liter Astron i4. This was a reliability nightmare for small truck owners. Used in the Mighty Max and Dodge Ram 50, this engine suffered from multiple design flaws that cut its lifespan short and made it a headache to maintain. One of its biggest issues was excessive heat buildup. The aluminum cylinder head was prone to warping under even mild overheating, leading to head gasket failures that often appeared before 100,000 miles. Once the head warped, repairs weren't always effective, and some owners had to replace the entire top end. Worse, cracks between the valves weren't uncommon, leading to coolant leaks and compression loss that could make the engine undrivable. The timing chain system was another weak point. Instead of a durable setup, Mitsubishi used plastic chain guides that wore out quickly. As they degraded, the chain loosened and started rattling against the timing cover. If ignored, it could jump timing or snap, often destroying the valve train. Many owners had to replace these components well before 120,000 miles just to prevent catastrophic failure. Oil leaks were nearly impossible to avoid. The valve cover, front crank seal, and balance shaft seals all had a habit of leaking, sometimes so severely that oil dripped onto hot exhaust components, causing smoke and burning smells. Low oil levels further accelerated internal wear, and many of these engines didn't make it past 180,000 miles without needing a complete rebuild. Compared to other four-cylinder truck engines of the era, the Astron was noticeably less durable. While competitors like the Toyota 22R and Nissan Z24 routinely exceeded 300,000 miles with minimal fuss, this engine often struggled to make it half that distance without major issues. Poor longevity, constant oil leaks, and an unreliable timing setup made it one of the most failure-prone engines ever installed in a compact pickup. At number 31, we have the Volkswagen 1.6-liter diesel. This was installed in the 1980s VW Caddy pickup and was one of the most underwhelming small truck engines ever built. It was painfully slow, barely managing 52 horsepower, making even basic highway speeds a struggle. This lack of power forced the engine to work harder than it should, leading to premature wear and reliability issues. Timing belt failure was one of its biggest flaws. If not replaced precisely at the recommended intervals, often before 100,000 miles, it would snap, causing catastrophic valve and piston damage. Many owners learned this lesson the hard way, facing complete engine rebuilds far earlier than expected. Cooling system failures were another weak point. Thin cylinder heads were prone to warping, and head gasket leaks were so common that they became a routine repair. Overheating was a frequent issue, sometimes leading to complete engine failure before 150,000 miles. Oil flow problems further shortened its lifespan, with worn camshafts and excessive sludge buildup being common. While diesels like the Mercedes OM616 and Toyota 2-liter were known for exceeding 400,000 miles with ease, the VW 1.6-liter often struggled to make it past 250,000 miles without requiring major repairs. On to number 30, it's the Chevy 2.2-liter inline-4. Chevy's 2.2-liter inline-4 was meant to be an economical, no-frills option for the S10. Instead, it became a lesson in why underpowered engines don't belong in trucks. With a pathetic 118 horsepower and 130 foot-pounds of torque, this thing struggled to get out of its own way. Hauling even a modest load felt like dragging an anchor, and highway merging required nerves of steel. It wasn't just slow, it was also fragile. The 2.2-liter was notorious for burning oil, blowing head gaskets, and spinning rod bearings. Timing chain tensioners were a known weak spot, and when they failed, which they did, the engine was done. Cracked cylinder heads were another common problem, often surfacing before 100,000 miles. This engine found its way into base model Chevy S10s and GMC Sonomas, but many owners regretted the choice. GM issued multiple service bulletins for oil consumption and cooling system issues, but reliability never improved. At best, the 2.2-liter was a commuter-grade engine stuffed into a truck that deserved better. At worst, it was an expensive mistake waiting to happen. Anyone who had one either swapped in a 4.3-liter V6 or traded their truck for something with actual power. The bottom line, the 2.2-liter was slow, fragile, and one of the least loved pickup truck engines Chevy ever built. The V6 was always the better choice. Sliding in at number 29, it's the Dodge 5.9-liter Cummins. This engine had a legendary reputation, but the late 90s to early 2000 models had a serious weak link: the VP44 injection pump. When Dodge updated the 12-valve 5.9-liter to the new 24-valve design in mid-1998, they swapped out the old mechanical P7100 pump for the electronic VP44. That decision turned out to be a disaster. The VP44 was fragile, expensive, and prone to early failure. It relied on a lift pump to supply fuel, but the factory setup was poorly designed. When the lift pump failed, a common occurrence, the VP44 was left running dry, leading to overheating and internal failure. Once the VP44 went, your truck wasn't going anywhere without a costly replacement. This engine powered the Ram 2500 and 3500, but many owners found themselves stranded thanks to the unreliable fuel system. Even worse, the VP44's electronic control module was known to fry due to voltage spikes, adding another expensive headache. Dodge never truly fixed the issue, leaving many to install aftermarket lift pumps just to keep their trucks running. While the 5.9-liter Cummins itself was solid, the VP44 was a major blemish on an otherwise bulletproof engine. Many owners swapped to a mechanical P-pump conversion or later models with the common rail system, anything to escape the nightmare of the VP44. And at number 28 is the Isuzu 2.2-liter C223. This diesel engine was supposed to be a fuel-sipping workhorse for small pickups like the Isuzu pickup and Chevy LUV. Instead, it turned into an exercise in frustration for anyone who needed a truck that actually started reliably. While diesel engines were known for their longevity, this one had a fatal flaw: its weak fuel injection system. Cold starts were the biggest issue. The glow plug system was notoriously unreliable, leading to endless cranking on chilly mornings. Even when warm, the engine often hesitated to fire up, thanks to worn-out injectors and failing injection pumps. Many owners resorted to ether starting fluid just to get their trucks running, which only made long-term reliability worse. Once running, the 2.2-liter wasn't exactly inspiring. With around 58 horsepower and 93 foot-pounds of torque, it struggled under load. Hills turned into endurance tests, and towing was more of a suggestion than a capability. Fuel economy was decent, but that meant little when owners were stuck in their driveways, unable to start their trucks. High maintenance costs sealed the engine's fate. Injection pump rebuilds were expensive, glow plugs failed regularly, and cracked cylinder heads were common. By the late 80s, most owners either swapped in a gas engine or ditched the truck entirely. The 2.2-liter diesel might have been efficient, but it was too unreliable to earn a place in pickup history. At number 27 is the Dodge Rampage 2.2-liter inline-4. The Dodge Rampage was already an oddball, a front-wheel drive unibody truck based on a car platform. But its biggest flaw wasn't the design. It was the 2.2-liter inline-4 under the hood, an engine that simply had no business being in a pickup, even a small one. With just 84 horsepower and 111 foot-pounds of torque, the Rampage's 2.2-liter struggled with even the lightest loads. Acceleration was glacial, and highway merging felt like a gamble. The engine had to be wrung out to get any usable power, but even then, it never felt like it had enough grunt to justify calling the Rampage a truck. Reliability was another weak point. These engines suffered from head gasket failures, oil leaks, and timing belt issues. The carbureted versions were finicky, often plagued by rough idling and poor cold start performance. Later fuel-injected models improved durability, but didn't fix the fundamental problem. This engine simply wasn't cut out for the demands of a pickup. Dodge had aimed for fuel efficiency, but in a segment where capability mattered more, the Rampage's 2.2-liter was a deal-breaker. Most buyers wanted power, and this engine just didn't have it. The Rampage disappeared after a short run, and so did any hope of a front-wheel drive Dodge truck making an impact. At number 26, it's the Land Rover 2.5-liter TD5 diesel. This was supposed to be a modern leap forward for Land Rover's workhorse Defender lineup. Introduced in 1998, the 2.5-liter 5-cylinder turbo diesel brought electronic controls to an engine family that had long been known for rugged simplicity. Unfortunately, the modernization came at a cost, specifically reliability. While the TD5 had decent power for its size, 122 horsepower and 221 foot-pounds of torque, it was notorious for mechanical failures. One of the biggest problems was head gasket failure, which could lead to coolant leaks, overheating, and ultimately a cracked head. Even worse, some TD5s suffered from oil pump drive failures. If the drive sprocket detached, the engine was starved of oil and would grenade itself in short order. The electronic unit injectors were another weak point. The injector harness was prone to leaking oil into the wiring, causing electrical failures and misfires. And because Land Rover packed the engine bay tightly, basic maintenance jobs often turn into wallet-draining repair bills. For an engine meant to power a go-anywhere, do-anything off-roader, the TD5 was frustratingly fragile. The Land Rover 2.5-liter TD5 diesel engine was eventually discontinued because Land Rover sought a more modern, powerful, and refined replacement, opting for Ford's Duratorque Puma engine, which was the last engine built in-house at Solihull. Slotting in at number 25 is the Opel 2.5-liter TD inline-4. Introduced in the early 1990s for the Opel Campo pickup, this engine suffered from severe cylinder head cracking. Opel altered the original Isuzu casting, resulting in a weaker head structure that developed stress fractures, especially under prolonged use. Once the cracks formed, coolant leaked into the combustion chamber, leading to hydrolock, misfires, and total engine failure. The piston rings wore prematurely, causing excessive blow-by and oil consumption. This led to carbon buildup in the combustion chamber, reducing efficiency and further stressing the already fragile internals. Engines frequently burned oil at low mileage, requiring full rebuilds to restore compression. The fuel injectors, built around a Bosch rotary pump system, suffered from internal seal failures. Diesel leaked past the seals, diluting the engine oil, which thinned out lubrication and accelerated crankshaft and camshaft wear. This often resulted in spun bearings and seized engines far earlier than expected. By the late 1990s, the Opel 2.5-liter TD inline-4 was abandoned due to its cracked heads, oil dilution, and premature internal wear, making it one of the most failure-prone diesel engines Opel ever used in a pickup. And at number 24, it's the Ssangyong 2-liter diesel. Introduced in the early 2010s for the Action sports pickup, this engine was plagued by severe reliability issues that made it one of the worst diesel engines fitted into a pickup. Developed as a downsized alternative to Ssangyong's larger diesels, it failed due to poor durability, weak internals, and constant fuel system failures. A major flaw was excessive connecting rod bearing wear, which led to low oil pressure and eventual crankshaft failure. The bearings degraded far too quickly, often within 50,000 miles, causing metal shavings to circulate through the engine and destroy key components. Once the crankshaft was compromised, engine knocking and catastrophic failure followed, requiring a full rebuild. The fuel injection system, built around a Delphi common rail design, was another major weak point. Poorly designed injector seals allowed diesel to leak into the oil system, thinning lubrication and accelerating camshaft wear. Many owners reported cam lobes wearing down prematurely, leading to valve timing issues, misfires, and total power loss. Excessive carbon buildup in the intake ports further choked performance. The Ssangyong 2-liter engine's EGR system was prone to clogging, causing rough idling, hesitation, and complete stalling under acceleration. These issues, combined with high repair costs and frequent engine failures, led to the 2-liter diesel's early exit from the Action sports pickup lineup. On to number 23 with the Mahindra 2.2-liter M-Hawk diesel. This was first introduced in 2008 and was used in the Mahindra Scorpio getaway pickup, also known as the Mahindra pickup in various international markets throughout the 2010s. This engine was Mahindra's attempt to modernize its diesel lineup with a common rail system for improved fuel efficiency and emissions compliance. However, it quickly developed a reputation for injector failures, weak bottom-end durability, and turbocharger reliability issues, making it a high-maintenance and problematic power plant. One of the most significant issues stemmed from its common rail injectors, which were extremely sensitive to fuel quality. Even slight contamination led to injector clogging, poor spray patterns, misfiring, and eventual failure. Many Scorpio getaway owners experienced rough idling, excessive smoke, and severe power loss, often requiring costly injector replacements within the first 50,000 miles. The bottom end of the engine was another weak point. The crankshaft bearings suffered from inconsistent lubrication, which often led to spun bearings, low oil pressure, and in severe cases, catastrophic engine failure. The variable geometric turbocharger used in the M-Hawk was also problematic. Its actuator frequently failed, leading to erratic boost delivery, turbo lag, and surging under acceleration. Between fuel injection failures, unreliable turbo performance, and bottom-end durability issues, the 2.2-liter M-Hawk diesel in the Mahindra Scorpio getaway pickup became known for its high ownership costs and frequent mechanical failures, forcing Mahindra to revise the engine in later iterations. Number 22, we have the Tata 2.4-liter Dicor diesel. The Tata 2.4-liter Dicor diesel, launched in 2007 and used in the Xenon pickup throughout the 2010s, was Tata's attempt at a modern common rail diesel. Designed to replace the older, less efficient 3.0-liter Dicor, It promised improved fuel economy and emissions compliance. However, persistent electrical faults, fragile bottom end components, and an unreliable EGR system made it a disaster for pickup owners. From the start, electronic control unit glitches plagued the engine. Poor software calibration led to random stalling, erratic throttle response, and limp mode activation. Crankshaft and map sensor failures were common, resulting in hard starting, misfires, and unexpected shutdowns. The EGR system was another weak point. Excessive soot accumulation clogged intake passages, suffocating the engine and leading to severe power loss, rough idling, and black smoke. Many Xenon owners resorted to manually disabling the EGR to keep the engine running smoothly. Structurally, the crankshaft bearings and connecting rods were under-engineered, leading to low oil pressure, premature bearing wear, and bottom-end failures. Many engines suffered from spun bearings and rod knock well before 100,000 miles. With frequent breakdowns and expensive repairs, the 2.2-liter Dicor diesel quickly gained a reputation as an unreliable power plant, forcing Tata to revise it in later models. In at number 21, it's the Great Wall 2.4-liter inline-4. The Great Wall 2.4-liter inline-4 gasoline engine was launched in the early 2010s and was used in the Great Wall Wingle 3 and Wingle 5 pickups. Marketed as a simple, durable workhorse, it instead turned out to be a poorly engineered, inefficient, and unreliable engine that struggled to meet expectations in both performance and longevity. One of the biggest weaknesses was fuel economy, or the lack of it. Despite being a naturally aspirated four-cylinder, it drank fuel like a V6, with real-world mileage figures far worse than advertised. The issue stemmed from an outdated fuel injection system which struggled with precise fuel metering, causing poor combustion efficiency and excessive fuel consumption. Owners of the Wingle 3 and Wingle 5 pickups often reported getting significantly lower MPG than competing trucks with similar displacement engines. Reliability was another major concern. The timing components, especially the chain tensioner and guides, wore out prematurely, leading to chain stretch, misaligned timing, and in some cases, complete timing failure, resulting in bent valves and engine destruction. Between horrendous fuel economy, weak internals, excessive oil consumption, and chronic overheating, the Great Wall 2.4-liter inline-4 in the Wingle 3 and Wingle 5 pickups was a textbook example of an underdeveloped engine that failed to deliver durability or efficiency, making it one of the most problematic small truck engines of its time. At number 20, it's the Subaru 1.8-liter EA81. The Subaru 1.8-liter EA81 engine used in the Subaru Brat during the 1980s was a weak, underpowered flat four that had no business in a pickup truck. Designed more for fuel efficiency and simplicity rather than hauling or towing, it struggled to deliver usable power for anything beyond light-duty driving. With a measly 73 horsepower and 94 foot-pounds of torque, the EA81 was severely underpowered. Its pushrod design and small displacement meant it lacked both low-end torque and top-end power, making highway merging and hauling loads an exercise in frustration. Owners often had to rev it hard to extract what little performance it had, leading to premature wear on the valve train and increased oil consumption. Durability also suffered due to poor head gasket reliability, a common issue in older Subaru engines. Many owners faced coolant leaks, overheating, and eventual head warping, requiring costly repairs. The intake manifold gaskets were another weak point, leading to vacuum leaks, rough idle, and inconsistent throttle response. While the EA81 was reliable in small cars, it was completely unsuited for a truck application. Its lack of power, weak torque delivery, and high revving nature made it one of the worst engines ever put in a pickup. Up next at number 19 is the Changan 1.5-liter petrol. First appearing in the early 2010s, the Changan 1.5-liter petrol engine was supposed to power the Changan Star pickup with efficiency and reliability. However, it turned out to be gutless, impractical, and completely inadequate for any real truck use. With just over 100 horsepower and a weak torque curve, this engine had no usable pulling power. Hauling even modest loads sent the engine into a constant struggle, requiring excessive revs just to keep up with traffic. The tiny displacement and lack of low-end torque meant that even with an empty bed, acceleration was sluggish. The moment a load was added, it became painfully slow, often forcing drivers to shift gears aggressively just to maintain momentum. Reliability wasn't much better. The timing chain tensioners were known to fail prematurely, leading to slack in the chain and erratic timing. Fuel system issues were another headache, with injectors prone to clogging, causing misfires and poor throttle response. Add to that excessive oil consumption after just a few years, and the engine quickly became a maintenance nightmare. Designed for small vans and budget vehicles, the Chang'an 1.5-liter had no business in a pickup truck. It was slow, inefficient, and utterly useless for hauling, one of the worst small pickup truck engines of its time. And on to number 18, it's the Jack 2.8-liter diesel. Launched in the early 2010s, it was marked as a durable workhorse for the Jack T6 pickup, but in reality, it was anything but. While 2.8 liters sounds reasonable for a diesel truck engine, the Jack 2.8-liter diesel suffered from major reliability issues that made it a complete failure. One of its biggest weaknesses was chronic fuel injector failures. The common rail injection system was poorly designed, with injectors that clogged and failed at an alarming rate. Owners frequently experienced rough idling, loss of power, and excessive smoke, often within just a few years of use. Replacement injectors were expensive, and many drivers found themselves replacing them multiple times, making ownership a costly nightmare. The Jack 2.8-liter diesel also struggled with poor emission system design. The EGR valve was a major trouble spot, prone to clogging with carbon buildup, leading to reduced engine performance, stalling, and eventual failure. In markets with stricter emission standards, the engine often failed to pass inspections, forcing costly repairs or outright replacement. Adding to its woes, the Jack 2.8-liter diesel suffered from excessive oil leaks, often from the valve cover and turbo seals, which further contributed to reliability problems. While Jack may have hoped this engine would make their T6 pickup a contender in the global truck market, it instead became known for constant repairs, emissions headaches, and expensive injector replacements. In the number 17th position is the Ford 2.9-liter Cologne V6. Launched in 1986, it was intended as an upgrade over the aging 2.8-liter version, offering fuel injection and slightly more power for compact trucks like the Ford Ranger and Bronco 2. However, this engine turned out to be a reliability nightmare due to one catastrophic flaw: weak cylinder heads that cracked under normal use. The 2.9-liter Cologne V6 had poorly designed cast iron heads with thin water jackets, leading to frequent overheating and stress fractures. Even with routine maintenance, the heads developed cracks, allowing coolant to mix with oil, which is not a good thing. This contaminated lubrication system led to premature bearing wear, loss of oil pressure, and eventual engine failure. Many owners experienced white smoke from the exhaust, coolant loss, and overheating, often requiring expensive head replacements, sometimes multiple times over the engine's lifespan. Even aside from the head issue, the 2.9-liter Cologne lacked low-end torque for a truck engine, making it feel sluggish when towing or hauling. By 1993, Ford abandoned the 2.9-liter entirely in favor of the 4-liter Cologne V6, which resolved the durability issues and made the underwhelming, failure-prone 2.9-liter obsolete. And on to number 16, we have the Mitsubishi 3-liter V6. This engine was introduced in the early 1990s, and it was supposed to be a refined, fuel-injected alternative to Mitsubishi's smaller 4-cylinder engines. Used in the Mighty Max pickup, this engine aimed to deliver better performance and smoother operation, but it ultimately failed as a truck power plant. It lacked the torque needed for serious work, had questionable long-term durability, and suffered from a notorious oil consumption issue that turned into a costly problem. The biggest mechanical flaw in the 3-liter V6 was its premature valve stem seal wear, which led to excessive oil burning. Many owners noticed the engine consuming oil at an alarming rate after just a few years of use. Beyond oil issues, the 3-liter V6 simply didn't belong in a pickup truck. It lacked sufficient low-end torque, making it struggle under load, whether towing or hauling. Despite its unimpressive power output, its fuel economy was nearly as bad as a larger, more capable V6, leaving owners stuck with a gutless engine that still burned fuel at a high rate. By the late 1990s, the 3-liter V6 had built a reputation for being weak, inefficient, and prone to oil consumption, pushing many Mighty Max owners to seek out engine swaps or simply move on to better trucks. On to number 15, and we have the Nissan Titan XD 5-liter Cummins V8 diesel. Nissan had big ambitions when it stuffed a 5-liter Cummins V8 diesel under the hood of the Titan XD in 2016. The idea? Bridge the gap between half-ton and heavy-duty trucks, giving buyers a beefier workhorse without the full HD weight. But then reality hit hard. At first glance, the turbocharged 5-liter Cummins looked like a solid power plant, cranking out 310 horsepower and 555 foot-pounds of torque. It had the right numbers, a solid nameplate, and promised the diesel durability truck buyers crave. So, what went wrong? Failure came fast. Owners quickly found out this engine wasn't a bulletproof Cummins inline-6. It was an entirely different beast. The complex emission system was a nightmare, with EGR and DEF system failures leading to frequent dealer visits. Turbocharger failures were another common issue, with some trucks needing replacements before hitting 50,000 miles. The fuel system was another money pit. Injectors clogged, fuel pumps failed, and this CP 4.2 high-pressure fuel pump was notorious for grenading, potentially wiping out the entire system. By 2019, Nissan threw in the towel. The 5-liter Cummins was axed, leaving behind frustrated owners, warranty fights, and a truck that never lived up to its diesel promise. At number 14 is the Chrysler raised block engine. This was Mopar's answer to the growing horsepower wars of the late 50s and 60s. As the big brother to the B-Series engines, it ranged from 383 cubic inches to a monstrous 440, powering everything from Chrysler Imperials to Dodge trucks. But while it had its moments of glory, the RB wasn't exactly a flawless workhorse, especially in pickups. Why? Size, weight, and inefficiency. The RB was a massive iron block that guzzled fuel like there was no tomorrow, making it a poor fit for work trucks that needed reliability over brute force. Even with its torque-heavy nature, the long stroke and heavy internals meant it never revved freely, and the weak oiling system made it prone to premature cam and lifter wear. Cooling was another Achilles heel. The 440 in particular was infamous for overheating, especially in trucks that did heavy towing. Factory cooling systems just couldn't keep up, leading to head gasket failures and warped heads. Then came emissions regulations in the 70s, strangling the RB's power with leaner carb tuning, lower compression, and choked off exhaust flow. By 1978, Chrysler pulled the plug. The LA Series small blocks took over, leaving the RB as a relic of an era when bigger wasn't always better. At number 13, it's the Dodge 318. This engine debuted in 1957 as Chrysler's small block workhorse, designed to balance efficiency and durability. Over the years, it powered everything from D-Series pickups to early Ram trucks, sticking around for decades thanks to its bulletproof reputation. But while the 318 was nearly impossible to kill, it was never a powerhouse, especially in trucks. Dodge positioned it as a reliable, fuel-friendly alternative to larger V8s, but the reality was underwhelming torque and sluggish performance. Even in its later Magnum 1992 to 2002 form, the 318 struggled to move heavy loads, barely putting out 230 horsepower and 300 foot-pounds of torque. Earlier carbureted models were even weaker, and as emissions regulations tightened in the 70s and 80s, power output dropped further. Truck owners trying to tow or haul quickly found that the 318 needed constant revving just to keep up, something competing engines like the Ford 351 Windsor and Chevy 350 handled with ease. Despite being stubbornly reliable, the 318 was never the right fit for heavy-duty work. By the early 2000s, it was clear. Dodge needed more muscle, and the 5.9-liter 360 V8 and modern Hemis took over. While Mopar fans still respect the 318 for its longevity, in the truck world, it was more of an anchor than an asset. At number 12, we have the GM 2.8-liter V6. It arrived in 1980, built as a compact, fuel-efficient alternative to the traditional small-block V8s. It found its way into a variety of GM vehicles, including the Chevy S10, GMC S15, and early Colorado and Canyon pickups. The idea was to offer truck buyers a thrifty option, but the execution left a lot to be desired. Right from the start, the 2.8-liter lacked the power needed for truck duty. With only 110 to 125 horsepower and around 150 foot-pounds of torque, it struggled with even light hauling. Acceleration was laughable, and if you dared to tow, the engine felt completely overwhelmed. Things improved slightly with fuel injection in the late 80s, but by then, the damage was done. Truck buyers wanted power, not just fuel savings. Then came the durability issues. Weak head gaskets, poor oiling, and timing chain failures plagued early models. The crankshaft and camshaft were known to wear prematurely, leading to expensive rebuilds long before a truck's body showed its age. Overheating was another common issue, especially in hot climates where cooling systems often struggled to keep up. GM eventually ditched the 2.8-liter in favor of the 4.3-liter V6, which delivered actual usable torque. While the 2.8-liter worked fine in small cars, in pickups, it was an underpowered, failure-prone mess that never should have been there in the first place. On to number 11, it's the Lincoln 5.4-liter dual overhead cam 32-valve Intech V8. This engine took center stage in 1999 under the hood of the short-lived Lincoln Blackwood, Ford's first attempt at a luxury pickup. Borrowed from the Lincoln Navigator, this high-revving dual overhead cam engine looked great on paper, until real-world truck owners got their hands on it. At 300 horsepower and 355 foot-pounds of torque, the Intech V8 had decent power, but it was designed for smooth highway cruising, not hauling or heavy-duty work. Unlike Ford's truck-tuned pushrod V8s, the dual overhead cam setup prioritized high-end power over low-end grunt, exactly the opposite of what a truck engine needed. Worse yet, it was thirsty, chugging fuel without delivering the kind of torque truck buyers expected. Then came the reliability issues. The plastic intake manifold was notorious for cracking, leading to coolant leaks and overheating. Cam phaser problems and timing chain failures were also common, with expensive repairs that often required tearing the entire engine apart. The complex design made basic maintenance a nightmare, driving up ownership costs. The Blackwood was a sales disaster, and Lincoln quickly pulled the plug after just one model year. Ford never tried another dual overhead cam V8 in a pickup again, proving that luxury car engines and truck duty just don't mix. Slotting in at number 10, it's the Caterpillar 3116. This engine hit the scene in the late 1980s, designed for medium-duty trucks and workhorses like the Chevy Kodiak, GMC Topkick, and Ford F650 and F750. With the Cat name behind it, expectations were sky high. But what followed was a frustrating mix of mediocre performance, expensive repairs, and near zero tolerance for DIY fixes. For a 6.6-liter inline-six, the 3116 felt sluggish, producing 170 to 300 horsepower and 400 to 860 foot-pounds of torque. Not bad for lighter jobs, but grossly underpowered compared to Cummins and Detroit diesel alternatives. The biggest problem, it was mechanically injected, meaning no ECU to tweak or reprogram. If you wanted more power, you were out of luck unless you were willing to tear into the injection pump, a job best left to specialists with Cat's proprietary tools. Reliability was another sore spot. The 3116 was infamous for drop valves, weak camshafts, and head gasket failures, especially when subjected to heavy loads. Worse, Cat built the injectors directly into the cylinder head, so even basic injector maintenance meant pulling the entire head, an expensive, time-consuming nightmare. By the early 2000s, the 3116 was phased out in favor of the improved 3126. But for those who owned one, the damage was done. It proved that just because an engine carries the Caterpillar name doesn't mean it's bulletproof. Up next at number 9, it's the Chevrolet Silverado 2.7-liter turbo 4-cylinder. It made its debut in 2019, aiming to deliver V8-like performance with better fuel efficiency. Chevrolet pitched it as the perfect blend of power and economy, slotting it into the Silverado 1500 to attract buyers looking for a smaller, more efficient alternative to traditional truck engines. On paper, it had promise. 310 horsepower, 430 foot-pounds of torque sounded solid, but real-world performance told a different story. The biggest issue? Turbo lag and underwhelming towing capability. While the engine made plenty of torque, it lacked the immediate response of a naturally aspirated V8, leading to sluggish acceleration and inconsistent power delivery under load. The maximum towing capacity barely cracked 9,000 pounds, a number that didn't impress truck buyers accustomed to more robust options. Durability concerns also surfaced early. The 2.7-liter suffered from excessive oil consumption, carbon buildup, and lifter failures. Problems that should never plague a modern truck engine this soon. The active fuel management system, designed to improve efficiency, ended up causing more headaches with misfires and cylinder deactivation glitches. Despite a redesign in 2022, the damage was done. Truck owners value reliability and proven performance, and the 2.7-liter turbo failed to earn their trust, leaving it as one of the least desirable Silverado powertrains. Number 8 goes to the first generation 3.5-liter EcoBoost V6. The first generation 3.5-liter EcoBoost V6 debuted in 2009, promising V8 power with better fuel economy. Ford dropped it into the F-150, Expedition, and even the Lincoln Navigator, betting big on turbocharging in a truck market that still swore by displacement. With 365 horsepower and 420 foot-pounds of torque, the twin-turbo V6 could embarrass some V8s when it worked properly. The reality, early EcoBoost models became a nightmare for owners. The timing chain was a weak link, stretching prematurely and leading to rough running, loss of power, and potential engine failure. Cam phasers responsible for adjusting valve timing were another ticking time bomb, causing rattling, misfires, and costly repairs. Then there were the turbo issues. While turbos naturally wear over time, EcoBoost owners saw failures far too soon, often due to carbon buildup in the intake valves, a side effect of direct injection. Add in oil pan gasket leaks and constant spark plug replacements, and you had a truck engine that required far more babysitting than a traditional V8. Ford eventually ironed out these problems in later versions, but early EcoBoost buyers paid the price. While the engine helped push turbocharged trucks into the mainstream, the first-gen 3.5-liter was an expensive experiment that left plenty of owners regretting their choice. The number 7 spot goes to the Dodge 3.7-liter Magnum V6. It hit the scene in 2002. Serving as the base engine for the Dodge Ram 1500, Dakota, and Jeep Liberty. Chrysler marketed it as a more fuel-efficient alternative to the aging 3.9-liter V6, but in reality, it was a gutless, inefficient lump that barely improved on what came before it. With 210 horsepower and 235 foot-pounds of torque, the 3.7-liter struggled to move full-size trucks. It lacked the low-end grunt truck owners needed, making towing and hauling feel like an uphill battle. Even worse, fuel economy wasn't much better than a V8, which made buyers question why they were sacrificing power in the first place. Reliability, not its strong suit. The 3.7-liter was notorious for dropping valve seats, often leading to catastrophic engine failure. The rocker arms had a habit of popping off, causing misfires and requiring tedious repairs. Add in oil sludge issues from poor crankcase ventilation and timing chain tensioners that wore out too soon, and this engine quickly became a money pit. By 2012, Chrysler scrapped the 3.7-liter Magnum in favor of the 3.6-liter Pentastar, a far superior engine in every way. But for those stuck with a 3.7-liter, it was a decade-long lesson in why underpowered, overworked truck engines rarely last. At number 6, we have the Ford 2.7-liter EcoBoost V6. The Ford 2.7-liter EcoBoost V6 made its debut in 2015, positioned as a fuel-efficient, high-tech alternative to traditional V8s in the F-150. With 325 horsepower and 375 foot-pounds of torque, this twin-turbocharged V6 delivered strong acceleration, but its long-term reliability turned out to be a major letdown for truck owners. One of the biggest issues was the engine's compacted graphite iron block. While it was supposed to enhance durability, early models suffered from internal coolant leaks due to faulty head gaskets, causing overheating, misfires, and in some cases, complete engine failure. The dual injection system, meant to reduce carbon buildup, didn't fully solve the problem. Intake valves still got caked in deposits, leading to rough idling and loss of power over time. Worse, the oil pan was plastic, and many owners reported warping and leaks, resulting in a slow but steady oil loss. To make matters worse, early turbo failures weren't uncommon, especially under heavy towing. While later versions of the 2.7-liter EcoBoost improved on its shortcomings, first-gen owners were left dealing with an engine that wasn't built to withstand real truck abuse. The number 5 position goes to the Daihatsu Midget's 250cc ZA. This engine debuted in 1957, powering Japan's tiny 3-wheeled workhorse. Designed as an ultra-affordable, fuel-sipping alternative to full-size trucks, the Midget was a favorite among small business owners. But while the concept worked, the ZA engine itself was a serious weak link. With a microscopic 12 horsepower, the air-cooled single-cylinder 2-stroke engine was barely capable of moving the Midget, especially when loaded with cargo. Acceleration was non-existent, and top speed hovered around 30 miles per hour. Good luck climbing a hill with any kind of payload. Reliability? Not great. The air cooling system struggled in Japan's humid summers, leading to frequent overheating. The piston rings wore out quickly, resulting in poor compression, power loss, and clouds of blue smoke from burning oil. And because it was a 2-stroke, regular maintenance was a headache. Owners had to constantly mix oil with fuel, and carbon buildup in the exhaust port was a constant problem. By the mid-60s, Daihatsu upgraded the Midget with a 4-stroke engine, and the ZA was quickly forgotten. While the Midget itself became a cult classic, its original 250cc engine was an underpowered, high-maintenance relic that made even the slowest trucks feel fast. At number 4, we have the Honda Ridgeline's 3.5-liter J35A9 V6. Introduced in 2006, it was meant to bring Honda's reliability to the pickup world. With 250 horsepower and 247 foot-pound of torque, it powered only the first-gen Ridgeline from 2006 to 2014. While smooth and efficient, it struggled with durability under truck-like conditions, leading to its discontinuation in 2014. One of its worst flaws was cylinder number 4 failures, particularly in 2006 to 2007 models. Owners reported misfires, power loss, and head gasket failures, often caused by weak cylinder liners and localized overheating. Honda never issued a full recall, leaving many owners with massive repair bills. Another major headache was variable cylinder management, Honda's fuel-saving system that shut off cylinders under light loads. In reality, it led to excessive oil consumption, piston ring wear, carbon buildup, and premature spark plug failure. Some owners resorted to disabling VCM altogether to save their engines. Additional weak points included rear main seal leaks and timing belt tensioner failures, both of which could lead to costly repairs. By 2014, Honda discontinued both the first-gen Ridgeline and its troubled J35A9, replacing it in 2017 with the second-gen Ridgeline and an improved J35Y6 V6. While later versions were more reliable, early Ridgelines proved that not all Honda engines are bulletproof. And to number 3, we have the Cummins ISX. Introduced in the late 1990s, it was supposed to be the gold standard for heavy-duty performance, powering various Class 8 trucks and larger pickups converted for commercial use. It boasted up to 600 horsepower and 2,050 foot-pounds of torque, but its EGR system and emissions components turned it into an expensive liability. The biggest failure was the EGR system, which constantly clogged with soot, leading to overheating, valve failures, and cracked cylinder heads. Many trucks saw complete engine rebuilds before 300,000 miles, a death sentence in the diesel world. Then came the 2007 Plus versions with the DPF. The regen process overheated turbos and caused injector failures, leading to reduced power, endless downtime, and sky-high repair costs. On top of that, the camshaft lobes were notorious for premature wear, often requiring a full top-end rebuild. Another pain point was the fuel metering actuator, which failed unpredictably, causing rough idling, hard starts, or even complete shutdowns at highway speeds. Cummins attempted fixes over the years, but by 2010, the ISX had already built a reputation as a maintenance nightmare. Many fleet owners opted for pre-emissions engines or switched brands altogether, marking the ISX as one of Cummins' biggest disappointments in modern diesel history. And at number 2, it's the GM Toro Flow. Introduced in 1964, it was General Motors' ill-fated attempt at building a medium-duty diesel engine. Designed to compete with the rock-solid Detroit diesel and Ford diesel V8s, it was offered in the Chevrolet and GMC 40 to 80 series trucks. Based on the GMC 401 and 478 gasoline V6s, the Toro Flow was a gas engine converted to diesel, which we found out was a bad idea and sealed its fate from day one. Right away, the Toro Flow struggled with durability. Unlike true diesel engines, it lacked a purpose-built heavy-duty block and internals, making it prone to cracked heads, blown head gaskets, and excessive oil consumption. Many failed within 100,000 miles, a joke in the diesel world. The fuel system was another disaster. The Rusamaster rotary injection pump was unreliable and injectors clogged frequently, leading to hard starts, poor power, and constant downtime. The thin cylinder walls also suffered from cavitation, causing coolant leaks and internal engine failure. Torque was another weak spot. At only 235 to 280 foot-pounds of torque, the Toro Flow was massively underpowered compared to competitors. It was slow, inefficient, and unreliable, forcing many owners to swap them out for Detroit diesels or gas V8s. By 1972, GM killed the Toro Flow after just 8 years, cementing its legacy as one of the worst diesel truck engines ever built. And finally, at number 1, it's the Oldsmobile LF9 5.7 liter. Introduced in 1978, it was GM's rushed attempt at capitalizing on the fuel crisis by offering diesel efficiency in full-size cars and trucks. It was used in Chevrolet CK pickups, GMC Sierras, and Suburbans. But instead of being a true heavy-duty diesel, it was a converted Oldsmobile 350 V8 gasoline engine, a recipe for disaster. One of its biggest flaws was the weak block and head design. Since it was never meant for diesel compression, the head bolts stretched, head gaskets blew, and main bearings wore out prematurely. Many engines failed well before 50,000 miles, making warranty replacements a common occurrence. The fuel system was another nightmare. The Stanadyne DB2 injection pump was highly sensitive to fuel quality, and since many stations lacked proper diesel filtration in the late 1970s, the pumps and injectors frequently failed. Water contamination wrecked injection pumps, leading to hard starts, misfires, and total breakdowns. Adding insult to injury, GM recommended no glow plugs, opting instead for a weak intake grid heater, making cold starts miserable. Despite redesigns, the LF9's reputation was ruined. By 1985, GM axed the engine entirely, and its failure poisoned American buyers against diesel cars and light trucks for decades. The LF9 remains one of GM's most infamous blunders. If you love trucks and muscle machines, hit that like button and subscribe for more brutal breakdowns and legendary engines.